Let's begin with the next chapter, which is called Sequences and Series. Basically, the sequence is arrangement of elements written in a row. We can define a sequence in different manner as it is a function whose domain is the set of natural numbers. Now, to understand this, generally we write sequence as A1, A2, A3, A4, ... So, some elements are written in order in a row. That arrangement of numbers in that row is called a sequence. But we can look upon this sequence in a different way, as if I consider a function f, which is defined from the set of natural numbers to, say, r. By some rule, say f of n is n square. So, because here domain of this function is the set of natural numbers, the values of n would be 1, 2, 3, 4 onwards. So, if I find the values of the function, those are nothing but f of 1, f of 2, f of 3, f of 4, ... So, I am putting n equal to 1, 2, 3, I am getting values of this function f of 1, f of 2, f of 3, f of 4. But f of 1 by this rule is 1 square. F of 2 is 2 square by the rule. F of 3 is 3 square. F of 4 is 4 square. In general, you have n square ... So, as we know that this kind of arrangement of the numbers in a row is called what? A sequence. Therefore, one can look upon the sequence as a function also, because every natural number is related with what? Its square over here, and hence we can define as this is the first term, this is the second term, this is the third term, this is the fourth term. So, I am putting n equal to 1, 2, 3, etc. So, for finding the values of the function, I am using what? The natural numbers. As every time we are relating with the natural numbers, therefore, such kind of sequence is a function whose domain is the set of what? Natural numbers. So, by choosing the domain of the function as a set of natural numbers, if we consider the range set, that range set can be defined as what? A sequence. So, sequence is a function whose set of natural numbers, and the elements of the sequence are nothing but values of the function at the natural numbers. Now, if I denote this by A1, this by A2, this by A3, this by A4, ... this by an. So, I am getting the sequence A1, A2, A3, A4, ... an, which is over here. So, this is a sequence. Now, its nth term is given by an. And here, the formula for the nth term is what? N square. So, let us represent this sequence by writing its nth term in a bracket. So, when I write in a bracket an, by this notation, we mean this, and this is nothing but what? A sequence. So, A1, A2, A3, A4, ... an, and if I continue this, this is called what? An infinite sequence. And if I stop over here, then this is called what? A finite sequence. So, in short, a sequence which contains infinite number of terms is called an infinite sequence, and a sequence which contains finite number of terms is called what? A finite sequence. So, in two different ways, one can define a sequence. So, any sequence whose nth term is known can be represented by putting it in a bracket. So, bracketed an represents the entire sequence. So, bracketed an is this. For example, if I suppose consider an is equal to 2n minus 1, then bracketed 2n minus 1 would represent a sequence, because sequence is a function whose domain is the set of natural numbers. So values of n would come 1, 2, 3, 4. That way I am getting the terms of the sequence. So if I put n equal to 1 over here, 2 into 1, 2 minus 1 is 1. This is the first term of the sequence. If I put n equal to 2, 2 into 2, 4, 4 minus 1 is 3. So 1, 3, 5, 7, 9. This way I am getting a sequence. Let us consider one more example where an is given by something 1 by n into cos of n pi by 6. This is the nth term of the sequence. So what is the sequence? Let us write, put n equal to 1. So first term I am getting of the sequence 1 by 1 into cos 1 pi by 6. I am putting n equal to 1. So I am getting cos pi by 6. We know that cos pi by 6 is what? Root 3 by 2. So here I am getting root 3 by 2 multiplied by 1 by 1. So this is the first term of the sequence. Let us write the second term. A2 is given by what? 1 by 2 cos 2 times pi by 6. 2 pi by 6 is pi by 3 and cos pi by 3 is half. So 1 by 2 multiplied by half is the second term of the sequence. Now if I put n equal to 3 to get the third term of the sequence, I get 1 by 3 into cos 3 pi by 6. 3 pi by 6 is pi by 2. So cos pi by 2 is known to be 0. So 0 multiplied by 1 by 3 is 0. So third term of the sequence is what? 0. If I want to find the fourth term, let us put n equal to what? 4. 4 pi by 6, that is 2 pi by 3. So 1 by 4 already we have multiplied by cos 2 pi by 3 is minus half. So here I am getting the fourth term as 1 by 4 into minus 1 by 2 comma dot dot dot. So this way I am getting the sequence which is root 3 by 2, 1 by 4, 0, minus 1 by 8 dot dot dot. So this is the sequence whose nth term is given by this. So this entire sequence can be represented by putting its nth term in a bracket. So this sequence is nothing but bracketed 1 by n cos n pi by 6. So this way one can generate the terms of the sequence by putting the values of n always 1, 2, 3, 4 dot 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 in a formula so that sequence can be written down explicitly. So what is a sequence? It is a function whose domain is the set of natural numbers and the terms of the sequence are nothing but you are having certain formula to define the function. There you are putting the values of n 1, 2, 3. Hence the sequence can be known completely. Now suppose bracketed n is this sequence. I am considering this as infinite sequence, means n equal to 1, a1, a2, a3, a4, an dot dot dot. Suppose this is the sequence. Now if I am adding the terms of the sequence, what I get, some sum, let us denote it by what? S. So S is what? Sum of all these things, that is a1 plus a2 plus a3 plus a4 plus dot 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 plus an plus dot dot dot. Now this sum, which is obtained by adding the terms of the sequence, is called a series. So what is this? Is nothing but a series. So this is the series which corresponds to the sequence bracketed an, which is obtained by adding all terms of the sequence bracketed an. So this series is obtained by adding what? All the terms of the sequence. So it is represented by what? S. Now we can put this series in a notation which is called what? A sigma notation. Sigma notation means sigma is a capital letter of the Greek alphabet, means sum, it means what? The sum of what? All such things. So what we do, we take the general term of this, that is an, and this n is moving from 1, 2, 3 up to what? Infinity. So the whole series can be represented by writing in a sigma notation as sigma n goes from 1 to n. Essentially, we are picking up the nth term of the series. Behind that, we write the notation what? Sigma, and this n is moving from what? 1 to infinity. So if I want to open this sigma n going from 1 to infinity, we write for n 1, 2, 3, etc. and we add all those things. So for example, suppose sigma, we have bn or br, r going from 1 to 50. So in this sigma notation, if we open it by putting r equal to 1, 3 up to 50, then the whole series up to 50 terms can be seen b1 plus b2 plus b3 plus dot 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 plus b50. So I am putting r equal to first value of r 1, b1, then you say plus, put r equal to 2, you write b2, then you say plus b3, then you say plus dot dot dot, and the last value of r is what? 50. So this way I am getting what? b50. So sigma br can be expanded by putting r equal to 1, 2, 3, etc. up to what? 50. If you write something sigma cr, r going from 10 to 100, then the initial value of r is 10. So the first term would be what? C10. Next value would be what? 11. So this is C11. Then C12 plus dot 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 plus C100. So this way, sigma CR R going from 10 to 100 can be expanded to write this series. So what is a sequence and what is a series? That I told you. Sequence is a function whose domain is the set of natural numbers, and whatever elements we write in the sequence are nothing but values of the function at n equal to 1, 2, 3, etc. Whatever sequence we write, we add them to get what? A series, and that may be denoted by what? S. That can be written in sigma notation as follows. So sigma essentially a sum of all an, where n is moving from what? 1 to infinity. So this is infinite series, and this is what? A finite series, because it is going to end by the number 50. So b1, b2, b3 up to what? b50. There are only 50 number of terms in the series, hence this series is what? Finite series. So finite series and the finite series and infinite series, these are the two concepts related with the finite sequence and the infinite sequence. Simply you are supposed to add the terms of the sequence in order to get the corresponding what? The series. Now one more thing we will define is sum up to what? N terms of the sequence. Here suppose if I add only first n terms of the sequence, that is a1 plus a2 plus a3 plus dot 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 plus an, then this is the sum of first n terms, may be denoted by Sn. S for sum, and we are summing it from first onwards till what? The nth term. So Sn is the notation to represent sum of first n terms. I am not considering what? a3 plus a4 plus a5 plus dot 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 plus an plus 2. I am considering what? Sum from the first term till what? The nth term. That is denoted by what? Sn. Now if you know Sn, we can find the entire sequence. If you know the formula for the sum up to n terms of a sequence, then the whole sequence can be known. How? Idea is this. I want to find an to write the sequence by putting n equal to 1, 2, 3, etc. up to n. So Sn is given to us this. So what is Sn minus 1? Sn means what? The sum from the first term till nth term. So Sn minus 1 would be what? The sum from A1 onwards, A1 plus A2 plus A3 plus dot 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 plus An minus 1. If I take the difference of this, what I would get? Sn minus 1. Here, the term preceding An is An minus 1. The term preceding A4 is A3. Term preceding F3 is A2. Likewise, the term preceding An is An minus 1. So, if I take the subtraction, what will happen? A1 is cancelled. A2 is cancelled. A3 is cancelled. Likewise, An minus 1 is cancelled. What left is just this. So, this is An. So, nth term of the sequence is given by Sn minus 1. So, if you know the sum of the first n terms of the sequence, then by taking the difference of Sn and Sn minus 1, what you are getting? An, which is the nth term of the sequence. Once nth term of the sequence is known, you can write the entire sequence by putting n equal to 1, so A1, n equal to 2, so A2, n equal to 3, so A3. So this way, you are getting the entire sequence by knowing its nth term whenever the sum of the first n terms of that sequence is given. For example, suppose Sn is say 2n square plus 3n plus 1. If Sn is the sum of the first n terms of this sequence, question is, what is that sequence? Now, to find the sequence, it is enough to know the nth term of the sequence. Now, nth term can be known using the formula Sn minus 1. Means sum of the first n terms minus sum of the first n minus 1 terms. This difference is nothing but what? The nth term of the sequence. Now, in order to find Sn minus 1, we replace n by what? N minus 1. What we get is Sn minus 1 is equal to 2 into n minus 1 bracket square plus 3 into n minus 1 plus 1. Simply I am replacing n by n minus 1 in order to obtain Sn minus 1. So now An is given by Sn minus 1. That is, Sn is what? 2n square plus 3n plus 1 minus Sn minus 1 is what? 2 into n minus 1 bracket square plus 3 into n minus 1 plus 1. Now here we see that this 1 is getting cancelled. Now we can collect the terms in 2. So 2 is common. 2n square minus 2 into n minus 1 bracket square. So this is 2n into bracket what? N square minus n minus 1 bracket square. Plus then 3n, and this is 3 into n minus 1. We take 3 common. We take what? 3 common. So inside I get n minus n minus 1. 1 is already cancelled. Now what we are getting is 2 into bracket n square minus n minus 1 bracket square is what? N square minus 2n plus 1. Plus, here n is getting cancelled, minus minus plus 1 multiplied by 3 is 3. So here again n square is cancelled. So we are getting minus minus plus 2n multiplied by 2 is 4n. This is minus 1 multiplied by 2 is minus 2, and this is plus 3. So what you are getting, the nth term of the sequence is 4n. 3 minus 2 is 1. So this is 4n plus 1. So an, that is the nth term of the sequence, is 4n plus 1. So the whole sequence can be obtained whose sum of the first n terms is given by the formula 2n square plus 3n plus 1 is, put n equal to 1, you are getting 4 into 1 plus 1 is 5. 4 into 2, 8 plus 1 is 9. 4 into 3, 12 plus 1 is 13. Likewise, we are getting the sequence. So, sequence whose sum of the first n terms is given by the formula 2n square plus 3n plus 1 is given by 5, 9, 13, ... So, this way, whenever sum of the first n terms of the sequence is known, you can find its nth term and you can find the entire sequence by putting n equal to 1, 2, 3, etc. up to what? N, and so on and so forth.